All right. Hello, everyone. My name is Rob Secord. I'm the founder and the principal engineer of Charged Particles, and I'd like to just take a moment to welcome you guys to our quick little video. I don't want to take too much of your time. I know how much you guys love watching these videos, so let's just get right into it and get you guys hacking. I'll take a quick brief overview of the documentation site that we have, and then I want to give you a brief overview of the contracts and subgraph that will allow you to integrate with our protocol. So I'm just going to share my screen here. We'll jump right into the little presentation. So to begin with, our technical documentation, it's all available on docs.charge.fi. It's the central place to be for anything related to our protocol and when you're developing on our protocol with our API. What you might find there, to start with, we have a lot of guides on what charged particles is and how everything works. But you'll also find a lot of resources, such as our GitHub repository links to the contracts and to the subgraph. There's contract addresses listed there for mainnet and Covan, the subgraph playground. There's some reference material. There's some media and press kit material, logos, images, stuff like that. And there's also a glossary of terms for the charged particles universe. A lot of our terminology is based around the standard model of physics, so it's probably a good little bit of reading if you are not familiar with that. Once again, the main place to be, docs.charge.fi. So just remember that address and you should be good to go. And if you ever find yourself with any difficulties, just remember you can always reach out to us on the ETH Global channel on the Discord server. We have a private channel for charged particles on there, as well as you can always reach out to us on our main Discord server for charged particles. All right, so let's get into technical specs. Some of the stuff for the Solidity contracts that I want to mention right away, I'll try to be quick about. These are the main things you're going to want to use when integrating your application or your project with charged particles. So the main thing is mass and charge. The mass is the principal of the deposits that you put inside of your NFT. We consider that the mass, so the more deposits you have in your NFT, the kind of like the bigger your particle is. And then as interest accrue on those deposits, that interest is considered to be the charge. So the more charge your particle has built up. So of those two ideas, you can charge up your NFT and you can discharge your NFT and you can release everything from your NFT. And what we mean by that, when you energize, you're adding mass to the particle. So you're depositing assets into your particle. And we have two different rails for that. You can go through an Aave integration, and when you do so, your assets are automatically converted into an Aave interest-bearing asset, and your particle automatically starts generating charge. Or you can choose to go through a generic ERC20 rail, which will allow you to basically deposit any ERC20 into your NFT, but it won't necessarily generate a charge because most NFTs, or sorry, most ERC20s don't necessarily generate an interest based on a deposit. Once you have the mass in your NFT and is generating a charge, the owner of the NFT can discharge the particle, meaning they can remove some or all of the interest of that particle. You can choose to remove by amount, or you can just remove all of the charge. So that just means the mass will stay in your particle, but all of the interest will be removed. And then because there's still a mass in your particle, it will continue to generate interest over time still. It can also be discharged by the creator. And one of the nice features of charged particles is that we allow the creator to earn a portion of the interest in the NFTs that they create. And by doing so, of course, the creator can always come by later to their NFTs that they've created, even if they don't own them, and discharge that creator portion that is reserved for them. And then there's the release functionality. When you release, you're removing the mass and the charge. So you're going to pull out the interest portion and the deposit portion from the particle. And you can do this again by a specific amount, or you can just take it all out and leave the NFT empty for that specific asset type. When you integrate with charged particles, there's some certain settings that you'll be able to configure. If you've created your own NFT contract and you want to integrate your NFTs with charged particles, meaning you want your NFTs to be charged up with different types of assets, whether they're yield bearing or not, you can do so, and you can set requirements on your NFTs. So you can set specific requirements for the provider. For example, maybe only Aave is allowed to be selected, or maybe only the generic ERC20 types, or maybe only Compound in the future when we have an integration with Compound. And then you can also specify the exact asset type. So maybe it's only DAI or only USDC that you can deposit, as well as min and max deposits. There's a few settings you can set to allow your NFT to be charged up under your rules. Again, if you are going to integrate your own NFT contract, make sure you share your NFT contract with us in order to be included into the universe, so that our system recognizes your NFT contract and will then be supported. And another thing, when you do create your own NFT contracts, you want to support creators. And in order to do that, you want to basically expose a really simple creator of function. Most NFTs have an owner of, a balance of, so you might be familiar with these types of exposed functionalities already. So you just need to track in your NFT contract who created the NFT and just expose a creator of function that takes a token ID, returns an address. And you can see an example of all this in our contracts for the Proton. Our Proton contract has a good example of that. We also allow the NFT creator to set the percentage of the interest that will be reserved for them. So it could be 5%, it could be 15%. So as interest generates in your particle and you start generating a charge, the owner will get the bulk of that, the majority portion of that interest, but a small percentage can be reserved for the creator. And the creator can even redirect where they want that interest to go. So the interest could go to an external receiver address, which might be a treasury, an escrow, a loved one, a charity perhaps. Maybe you want to pass it down through the ages and have your children inherit it. There can always be a constant interest revenue stream for the artwork that you've created or for the NFTs that you've created. All right. Beyond just the creator of the NFT or the creator of the NFT contract, the owner of the NFT has a lot of settings that they can choose as well. Just like any NFT, you can manage approvals for your NFT, but this goes a little further than just transfer approvals. So we have discharge approvals, release approvals, and time lock approvals. So you can allow a third party to manage your token for you, and they can choose to discharge it, whether that be a third party game. Maybe you're playing a peer-to-peer battle, and the game is allowed to discharge the user's or the loser's token to the winner. Time lock, maybe a third party needs to be able to time lock your token for a loan, for example. You can manage your time locks, whether it's a discharge time lock or a release time lock. If it's a discharge time lock, that means the token cannot be discharged or released until the time lock's expired. If it's a release time lock, that means the token cannot be released until the time lock is expired, but it can still be discharged. You can also manage restrictions on your NFTs, so you can decide whether or not, by default, any NFT can have assets deposited into it by anyone. And as the NFT owner, you can restrict that and say, no, only I'm allowed to deposit into my NFT. Excuse me. You're also allowed to set the rules for discharging and release. By default, nobody but the owner is allowed to discharge and release the particle, but maybe you want to change that. Maybe the particle is a geocached item, and whoever finds the item is allowed to discharge it, but not release the base principal assets. So that way, it continues to generate interest for the next person to come along and find it. And again, that person then can discharge the particle. As you develop on charged particles, you might feel that Aave or Compound or some of the other yield providers we have isn't enough for your needs. So you can always add extra asset providers or yield providers. And you can do this by looking at our contracts Primarily two interfaces, the iWallet Manager interface and the iSmart Wallet interface. And your wallet manager would basically inherit from the wallet manager base and smart wallet based contracts. And again, there's code samples in our contracts code base. With a yield-based provider, you should manage the yield from the external liquidity provider and display that as a charge. From generic providers, of course, you just need to manage the asset, and there is no underlying charge because there's no underlying interest. There's a bunch of helper contracts in our library under the lib folder. And one particular contract that might be very helpful is the token info. And it's a lot of the mechanics used in our charged particles system. So if you want to get the unique ID of a token, the owner, the creator, the contract owner, the token creator, stuff like that, there's convenient functions in there to make your life a little simpler and make sure that you're integrating with charged particles in the same way that we do with our NFTs. There's other folders of note. There's the ABIs folder where you'll find all of the ABI files for all of our contracts. There's a deploy folder where you'll find the deploy scripts we use, which might be helpful when trying to figure out how the structure of the entire system works. The deploy files are a very good structured output of how we build up the entire universe. The deployments folder is output of all of our existing deployments, where you'll find contract addresses for various networks. And then there's the test folder, of course, for unit tests and integration tests, which might lend further assistance when trying to understand how the protocol works. Awesome. So we'll jump into the subgraph. We do have a hosted subgraph on the graph. The GitHub repo is on the docs. You can find it on the docs, but for quick reference, I have it listed here as well. We have one for mainnet and we have one for Covan testnet as well. And if you want something for dev or for localhost, feel free to deploy your own. And if you need help, reach out to us for help. We're always happy to help. And then when you integrate charged particles with your DApp, all you need to do is add the subgraph. So you would import the subgraph, which brings with it all of the ABIs for all of the contracts, as well as all of the current addresses for those contracts for the various networks, whether it be mainnet or Covan. Currently, the only testnet we support is Covan. Again, that URL that you want to remember is docs.charge.fi. That's the central place for all of the information you're going to need to help build on our protocol. And also, if you need to reach out on the Discord, please do. Please feel free to find us, ask us any questions that you might need, and we will help direct you. For a quick reference of the GitHub URLs that I've referenced, this is the Solidity Contracts. What you might want to look for is the interfaces that were pointed out. So these are the interfaces for the contracts. Take a quick reference, quick review of those. It will make you familiar with the API that we have exposed. We also have the subgraph. The subgraph is available here for your viewing. There's a test query that you can take right over to the playground and start playing with it immediately and seeing what kind of queries you can generate from the data we've logged. And this is our documentation. So once you come in here, you can see how we interface with the protocol. There are links to the GitHub repository, the subgraph playground, and there's contract addresses, for the link to the contract addresses. You can also find those here under contracts, of course. We have the main ones listed here. And then there's just some documentation around a lot of the common functions you might want to use to integrate your project with charged particles. And that's pretty much it. Thank you for watching, and happy hacking.